the supervised learning, as it is showing supervised, that means there is some supervisor. And what is our supervisor? The supervisor is the training data set plus the desired output. Okay, plus the desired output, or the labels are already available. Suppose I say that there are 4 sections, A, B, C, D, and randomly we pick one person. Then we have to say that which section this person belongs to. Okay, because the sections are already defined. Okay, that the output we know. Okay, what should be either the person, among your friends, the student will be either belongs to section A, B, C, or D. That's it. Those are the options. Okay, so that is called known as a supervised learning. Okay, and also there is some kind of prediction also you have to make it. That means given stock price of last 10 years. So you have to predict the stock price for the next 1 month or next day. Okay, for a particular brand or particular product. So that is also a supervised, because you know that what you are going to find out. Okay, the output your question is already given to you. Okay, then comes the unsupervised learning. In the unsupervised learning that we have the training data. Okay, also the testing data will be available. Okay, but what we do not have is the desired output. What we are going to look at. Okay, for example, although we have given all the marks to the students. Let's say in this course also, I am giving the marks to the students. So according to the students, I want that I should group the students into different categories. Different categories in the sense, I'll say that outstanding, excellent, good, then average, then bad, something like that. That 5 categories I want to segregate. All your 57 students I want to segregate. I will segregate based on the marks. But what you observe in the supervised and unsupervised is that in the unsupervised we do not have that tag already. Okay. In supervised I said that already there are 4 sections existing. Okay, and some of the students have already been tagged as this belongs to section A, these students belong to section B. Then we are taking another student of which we are predicting that which section that belongs to. And that section, how the section is divided? The section is divided based on the registration numbers. We have already known that. That is in supervised learning. But in case of unsupervised learning, what is that? We do not know the division. What is meant by outstanding performance? Have we decided? No, we have not decided. Okay. Alright, we have not decided how much mark students should get, so that they will be called as a outstanding student. Okay. Similarly, how much mark one should get, so that they will call as an excellent student. Okay, that is not decided. Okay, so that decision also you have to make. That is, roughly you can say here in the supervised the output level are given, but here you have to output level you have to create based on the data. Okay, that's the thing you have to do it in. That's the basic difference between these two. Okay, for example, here when I was saying that student belongs to some category, some section, then what I know that let's say roll number 1 to 60, section A, then 61 to 120, that is section B, then 121 to 180, that is section C, then 181 to 240, that is section D. We have already know. So if another student is coming, then we can always predict that which section it belongs to. That information, that category of that category of the registration number, the grouping, the lower bound of the registration number and the upper bound. The boundaries are already defined. Okay. Then you are doing a supervised learning there. Okay. But in this case, what happens? In this case, that boundary is not given. Okay. That is who is outstanding, who is excellent, who is good, who is average, and what is bad. That is not given. You have to produce that. For example, I can barely decide that, okay, let's from whoever has scored more than 80, they are outstanding. Whoever has scored more than 60 to 80, then they are excellent. Then 40 to 60, they are good. Then 20 to 40, they are average. Then below that, everybody is bad. Okay, that I can say barely. Understood? In case of unsupervised learning. But what is happening there? If I do that, suppose in your class, nobody has scored 80. So does it mean something? That means what? What is that meaning? If nobody has scored 80, more than 80 or 80, then what will happen? What are the consequences that you realize? Yes, I am asking you. You have to answer. I mean, you have to participate in the class.
The highest one is taken as outstanding performance.
No, if I take the rule that 80 to 100 is my outstanding, and then 60 to 80 is excellent, and 40 to 60 is good, 20 to 40 is average, below 20 is bad. So that way I had defined, but I found that nobody has scored more than 80. Then what will happen? Is my division or is my grouping is good? That may not be good, right? So if I'm also I'm finding that nobody has scored more than 60. So what will happen that upper two categories, outstanding and excellent, those two categories will having 0 students. Okay, which is not a good division or good ranking of those. Okay, or good grouping of those. So in that case, our division in this deterministic manner is not good. So what I should rather looked into, somebody was answering that I mean probably Uday was answering, is what the highest mark should be given as the outstanding, is it? Who was answering? Vanu Prasad. Okay, Vanu Prasad. Yes, I should know the name so that your CIQ will be improved. Okay. All right. So in that case, what will happen? Actually, what we are going to do is we are going to rank the students according to their marks, whether it is 40, 50, whatever. The highest mark we'll look into. Then we will go for quartile range. You have known the quartile, right? How to make the quartile things. Yes or no? So that quartile ranking, you have to see that first 25%, second 25%, second, third 25%, then fourth 25%. Depending on that, we'll decide that how much percentage should be getting good range. So that we can categorize it outstanding, then categorize it excellent, depending upon the marks, not depending on our deterministic rule that this range is excellent. That will not going to work. Okay, because the marks will vary. And I'm looking into section C only. If I look into another section, then the division should be different, right? Depending on their mark. So it should be a relative grading. So that kind of thing should be there. So we will be learning about something called K-means clustering. So with that, we can do this. Okay? Understood? Yeah. So yeah, if you have any questions on supervised and unsupervised learning, so please come back. Also, of course, I have some couple of more slides about it where maybe our idea will be clear. Yeah, I am also looking into all these Hrithik and all the volunteers. I'm really looking into people who will ask me questions. I'll be really happy to. So we talked about only one output. Okay. Let's say I said that grouping of that or classes of that. What is that? Which class or which section it belongs to? That one. Okay. If I do mix both the things, that means which section it belongs to and which category or which grade level, outstanding, excellent, extra it belongs to, then it will be having two things, two outputs. Okay. So in that case, semi-supervised, we have a label or we have a designation for one output, but we do not have a designation for the other output. Okay. For example, suppose I am saying you have randomly pick a student from second semester, then you have to guess which section it belongs to, and also you have to guess which category, I mean, outstanding, excellent, and this belongs to. So in that case, we will be already defining the sections ABCD and the ranges of that section, the registration number of the ranges of the registration number of the section, that we have already defined, but we do not define the categories, the level of the students, okay, or the division of the students, that is excellent, outstanding, that boundaries will not define, okay. So in that case, then the concepts semi-supervised. Of course, this is not in our course. We're not going to learn it. So we'll be learning, focusing on these two only. And coming back to reinforcement learning, also this is not in our course, but it's in the interest of knowing the overall idea of the machine learning, we'll have a brief over it. Okay? Then we have something called rewards and penalties from the actions. Suppose you are taking a step, one step. Okay? Step, that means the steps is right, then you are rewarded. If the steps is wrong, then you are getting a minus mark. Just like you might say, yeah, some of the games you might have played, right? Online games or mobile games or computer games you might have played, right? If you're taking, suppose that okay, I'm unable to hear you properly. So could you please type it in the chat box so that I will address your question? So I'm telling you that suppose there are some boxes are given. So you are playing a game. So in that game, suppose your robot is there. Your robot is stepping on a right box. Then some 20 birds will come up. So your robot is stepping on a wrong box. Then minus 10 will be there. So those kind of things. That means you understand that is the wrong way our robot is moving. So we have to again redirect the robot to a particular thing that is in a correct direction. So those kind of things are nothing but the reinforcement learning. So when, for best example is the self-driving car, okay? If they learn it, or the movement of the actual robot, that kind of, okay? Yeah. Anybody is typing in that chat box? Yeah. If you have questions, your voice is not clear, please type it in the chat box so that I'll address it, okay? I'll try. Okay. Hopefully, these things, a brief idea has been given to you. So hopefully, any questions or overall any questions on it, on this slide. And that means we have the labels or response or output variables. In the sense that whenever we are talking about data science and machine learning, we take all these things, all this data. When we talk about the data is having different columns. Do we agree? Or do we agree or not? We have different columns.
Yes, sir.
If you cannot answer, your voice is not clear, please take it in the chat box. So I'm looking on it. So if the class is not interactive, it means that nobody is learning. Okay. So if it is there, what is that? Label, sorry, all the columns. So, okay. What I'm going to do is I'm going to write also, so that probably you guys will get attention. Okay. Because in the slides, it's not slides is for the experts, and we have to stick to very small amount of text should be there. But in this case, okay. So whenever we're talking about the data, I hope it is visible, right? So in the data there are several columns. Yes or no? Understood?
Yes,
are you getting me? Okay. So all these columns, technically in this case, in the paradigm of data science and machine learning, we call them as features. Okay. So nothing to worry that what is a feature. Feature is just a column. Okay, one column. But out of this column, so also we can mathematically, when we are looking at the mathematics, we also call it as variable. Okay, we also call it as variable. All the columns. Okay. Or when you go to DBMS, it will be called as attributes. Okay, something like that. So, so out of these variables or out of these features, some features are for input. Okay, some features are for input. Okay, So this is for your note. You should actually note it down. Along with me, you should actually note it down. Some features are input features, some features or variables are output features. Okay? Got it? Are you following me?
Yes, sir.
Following me or not?
Yes, sir.
Okay? Some are student. Also, in mathematics, you'll be knowing that something called dependent variable. Okay? Sorry, this is input with independent variable. Okay? Have you learn about it or not? Independent variable?
Yes, sir.
Okay, very good. Okay, so independent variable, now there is the output variable is dependent variable. Okay, I hope you have learned. Okay, so I'm assuming that you know that. So yeah, apart from that, okay, if now I'll ask a question, let us clarify. I'm going to ask a question that what is this, somebody should answer. Okay, somebody means of course many of you can answer, but one by one you should tell your name, then you should tell that should I answer this one. Okay, that way. So I'm writing x is equal to, sorry, I'm writing y is equal to fx. Very simple. You might have seen it many times in the mathematics. So can anybody tell me which is the dependent variable and which is the independent variable? Yes, question to you.
Sir, y is dependent on
why the dependent variable x is independent, sir?
Sure?
Yes,
Are you
sir.
sure of it?
Yes, sir.
So
Yes, sir.
who answered actually? Who answered that one?
Danish.
Danish, okay. Very good, Danish. This is how class should progress. Yes, Danish is absolutely right. X is independent variable, and y is dependent variable. Okay? Because y is a function of fx. So if x value varies, okay, then y value is affected. Accordingly, the y value is decided. All right? I hope it is clear. Is other
Yes,
things
sir.
are clear?
Yes,
Okay,
sir.
okay, fine.
Yes, sir.
So what we have in machine learning, coming back to the machine learning or data science, what will happen that there will be several x and several y. Okay, why? So several x means this is a function we are writing. Okay, that is what, if that function is elaborated. So what is that? If I exactly tell y1 is a function of x1, yes or no? If I elaborate, because that x1 is a particular point. Okay, so in the coordinate system you can imagine x1, y1. That is one point. So it means that one. Okay, are you getting it?
Yes, sir.
I cannot draw it. It's a bit
Yes,
difficult, but I hope you understand. So y2 is dependent on the x2. So x2, y2 is another point. Yes or no? That is coming, right? Similarly, y3, that is coming. So y3 is the product of x3. Okay? Understood? Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
I hope you are getting, all of you are getting it in some manner or other manner. Oh, okay. So I should share this note probably, and you should write in a very beautiful manner for your understanding. Okay. And I am seeing that all the boys are responding, all the girls are silent. I mean, they are not participating in it. This is bad. Okay. So I'm saying yn. So yn depend on xn. Okay. This is the thing. Understood? I hope this is the thing. So you see that there are several x and y's. So y1 actually depends on the x1. Okay. If I elaborate it, tell that suppose a particular function I take it. What is that? Suppose that I'm writing a function of y is equal to, Suppose I am writing a particular function is y is equal to, y equal to, okay, y is equal to mx plus c. Okay, very simple. Which is, this is the equation of
Straight line.
equation of straight line. Fine, very good. Simple. That will be also learned in the regression. Okay, straight line. Check what is the straight line? What is a straight line? Or what is a line? Is it?
Collection of
So
points.
slope equal to 1.
It's a combination of multiple points. Yes or no? Roughly we can say that it's a combination of multiple points. Yes or no? Because a point is not a straight line. So multiple points, if they combine, then only it comes. So you can see that this is one point, x1, y1 is a point, x2, y2 is another point, x3, y3 is another point, and xm, yn is another point. Okay? So in that manner, you understand there are several points. Similarly, coming back to here, so there are features are available here. We are talking about only one feature, but in that feature also there are several points. I hope this is clear to you. Okay. Okay, so I am going to save it. Some extra notes are there, right? So at the end of the day, probably I'll share with you. So this is how the online class goes. Okay. So some kind of note. But you should write on your own how you are going to decide it. Okay. Notes. This notes is for date today is April 30. Okay. All right. And I have to make it a TXT, otherwise we will not be able to open it. All right. So I am saving it. So I'll share with you. Okay. If I forget, CR and volunteers should remind. I hope these things are clear. If these things are clear, then we can jump into learning about the other parts. This part. Okay. Is that okay? Now, is it looking complicated? Now, is it looking complicated? I hope you understand that, right? So, the labels or the response variables is already given in the supervised learning. So, we already know some of the Y's. We do not know all the Y's. If you look into here, that some of the Y's will be already known. Given X, what is Y, we have already the idea. Then, the question will be put like this, okay? Question will be put like this, okay? So if I'm taking yi, okay, yeah, so I am taking it underscore so for better understanding. So yi, what is yi given xi, okay? So that is the question mark we have been put. Understood? That is what is the supervised learning is. Because we have already known this, whatever is happening, y1 we know that, given that x1 what is y1 we know, given that x2 what is y2 we know already, given this x3 what is y3 we already know. Then we are taking a random xi, okay, random xi in that line, let's say, or around that line. Then what will happen? So we are asking that what is yi there, okay? All right. Are you getting, all of you getting it? Or is there any doubt? Okay, somewhat getting it. Okay, fine. Great. So let us come back to here. So that is what is there. So in supervised learning, we have a mapping from x to y. So we know some x dash is there, x double dash is there. So for x dash, we already know what is y dash. Okay, and we have to say, if given x double dash, what is would be the y double dash? That is what is we are asking. Okay, and this is nothing but a union. Have you learned about discrete mathematics already, or you are just starting?
Sir, it's going on, sir.
It's going on, right? So you might be aware of this symbol, right? What is this symbol?
Yes, sir.
Yes, sir.
What is it?
Union.
Union, right? Union. That means if I take a x dash and double dash union, then this will be x, means total set. Okay, this is a subset, or maybe 1 point, one element, this is another element. So if you combine all of this element, then we get the actual set, the total set. Similarly, y1 is an element, y dash is an element, y double dash is also an element. So if you combine this, it can be total y. Hope you understood it. Is there any questions now on supervised learning? So,
No.
okay. So remember that in computer science, many things will be given to you in this format, very cryptic manner, very mathematical manner. You have to understand. Somebody, I hope some of you might be aiming that you will be doing some MTech or PhD later on in your life. Okay. So for happens, the response or level, response variable or labels or output variable is unspecified here. That means you know the y, what is y. You do not know what is y. Sorry, we know the x. You do not know the y. You have to actually generate the y. All right. So given x dash, you have to generate y dash. Given x double dash, you have to generate y double dash, something like that. And similar thing, this union is same as previous one. Okay. Here mark that one. X is a mapping, supervised learning mapping from X to Y. Here there is no Y. You have to decide that Y. Okay. As I am saying that grouping of the students, you have to decide what is the range from mark this mark to this mark, so that we can say this is a outstanding student. What is the range for marks, so that we can say that one student is excellent. Okay. And what is the range of the marks, so that we can say that the marks is good. Okay, the student is good, something like that. So the labeling of that. Okay, is it clear? Unsupervised. Of course, I have some couple of examples over here, so don't worry. So we'll go also look into the example. Is that clear or not?
The supervised learning example.
It is coming up. It's coming up. All the examples are coming up. That is there. But in a broad picture, do you understand it mathematically or not? That's the question.
Can you explain
What is
the
the prediction?
Yeah, somebody is saying, can you explain what?
So that equation, sir.
Which equation?
Sir, X mapping y.
Yeah, X mapping Y is there, right? That is the thing that you are doing in the supervised learning. You have given X and some of our Y you know already. And some of the Y you have to consider, find out, figure out. Like this X and Y, X dash and Y dash both are known to you. Given X dash, you already know that what is Y dash. Okay? But for this X double dash, you do not know what is Y double dash. So that you have to calculate, or you have to categorize, or you have to classify that. Okay? That thing you have to do. So with the example, it will be clear. Okay? Understood? Yeah. And similarly, over here, there is no Y given. That will be a question definitely, but you have to figure it out that Y and what is the category. And I am saying that there are 5 different categories for the student depending upon the mark. You may decide that no, 5 categories is invalid, is not justified. You have to take 4 categories, or you have to take 3 categories. That is also possible, but depending upon the mark. Okay, all right. So that's there, depending on the mark. So we will decide that. So unnecessary will not have multiple groups. Okay. And coming back to reinforcement learning, as I was saying, the action, reward, or penalty. Depending on the action, that will be transformed to a reward or penalty. Okay. Similarly, there is something called meta-heuristic approaches, just like genetic algorithms, B-colony algorithms, and colony algorithms. There are many algorithms like that. So this reinforcement learning is a similar kind of story. Okay. So you have to do it. So of course, there are some examples coming up, so you'll be a bit clear on that. Okay. So what I'm going to do with that? Okay. So let's look at this supervised learning regression. Okay. There are I have already explained that there is regression and classification. So different things we will look into in the supervised learning. Okay. So that part we will look into. First, with the supervised regression we will look into, and you can see that there is some plot is given. Okay. So that is some kind of what is that? Here in the plot you can say that y is equal to wx plus w0. Okay. So it is the equation of the state time is given, W is slope, then W0 is the intercept, that means the x-intercept, wherever it is intersecting the x-axis. Okay, that is not shown here, but it will be. Then what will happen here? Here the problem is the mileage of the car is given. Okay, the example is price of a used for car. That means you have to predict the price of a car depending upon the mileage. Okay, what I'm saying, depending on the mileage, you have to predict the car price. Is the question clear?
Yes, sir.
Is the question clear
Yes,
or not? Yes. Yes.
Yes, sir.
Yes, sir.
So X is the car attribute is given. Here we have taken only one attribute, that is mileage. Okay, it is clear. Then Y is the price. So we can say that Y is equal to G X. Then also another thing we are taking theta. Theta is a constant. Okay, theta is a parameter, some other parameters. Theta is not a variable. This is a constant. Okay, which is called it as a parameter. Okay, so G is a model or G is a function. Okay, that instead of F I have written G. That's it. There is no difference. I have told you, right? I have shown you that Y is equal to Fx. Yes or no?
Yes,
So
sir.
instead of that, I am
Yes,
just
sir.
writing over here that
मेरा वास्ता
Y
क्या
is equal to Gx. It will
My
not be
count नहीं है.
affecting. It is the same thing. Okay. Same
Oh.
notation. Alright, I can write that. We are predicting the car price depending on the attributes, and here for simplicity we have taken only one
ये
attribute.
notes
That
जो
is
है
called
ना
a mileage. Okay. So if you know the mileage, can you
NTPNL
predict
वाले
the
से
price of the
जिससे हम
car?
पढ़ते हैं उसी से बनाएंगे.
That is the question that we are making it. And for that question, what is there? Can you see the cross? Whatever cross is there. Can you see that?
Yes, sir. Yes, sir.
So this cross is nothing but this is the already known thing. That means for particular x, you have already known the y. Okay. So that is why these points are already existing. This line, these points, these cross points are already existing. That is given to you. That means this is your training step. Okay, this is your training check. Okay. So in that case, what you are going to do for regression analysis, what you do, you just plot a line. Okay, the blue line, that is the straight line, that's a line. And for that line, this is the equation. Okay. Are you getting it? Any questions over here? Of course, in the regression part, we will be learning in details. But this overall part, do you understand what you are trying to do? How the line, okay, we will be learning linear regression, single linear regression, then multiple linear regression. Also, we will be learning about polynomial regression or non-linear regression. Okay? Is that clear? If you have any questions, please. If you have any questions, please write to me in the chat box or tell that. Okay. Okay. So depending on that, we are predicting. Now, I am asking you if the mileage is this much. You note my pointer. Note my pointer that the mileage is this much. Can you predict the price? Can you predict the price? Can anybody answer this one? Suppose I am saying this is my mileage. How do you do it? Deepak Kumar Das is speaking. But the voice is not. Alright. Fine. So there's another example over here, that is regression, application of the regression. Then how do you do it? We have seen one. Then another thing is that how much, according to kinematics, according to kinematics of that, how the steering should work. Okay. The left hand side picture, there is the steering of the work. How much should be the alpha? How much should be the alpha 1, alpha 2? Both you have to decide. Okay. Depending on that, it will be given some direction, given some running angle. Okay, like that should be decided. Similarly, on the right hand side, how much the kinematics of the robotic arms should be there. If there are two arms, this let's say the thicker one is the right hand, what is that, thin one is the left hand. So how the left hand, right hand should move so that the robot can perform some of the tasks. And you can see that there are blue dots where both the left hand and right hand are combined. So maybe you pick up some object or something else. Okay, that is what happens. So you can design that one with the regression also. Okay. So there is another example I would like to say that learning of this predict y given x to mapping is real valued regression. Okay, fine. So there are some year is given. So here the question is, our question is to find out the, depending upon the year, what is the sea ice. Okay, that is the area of the sea ice or the amount of sea ice that is we have to predict. Okay, actually this regression is type is something, mostly it is time series data. Okay, so what is given to us? X1, Y1, X2, Y2, Xn, Yn. Okay, here the year is the X year. Okay, here is the X year, and whatever the amount of the sea ice or what is Arctic, right? Arctic. So Arctic of the sea ice, that is the area of that sea ice. Up to that is given over the years. You can see that all the blue dots are nothing but the area over the years, maybe in different zones. Okay, so that much of kilometers and all these things. So these are going for the, if I take the different years, then what is the area that is given? Okay, then we have to predict that if we are in 2020 now, if we are in 2030 or 2050, what is the amount of this ice? You can say ice mountain or something like that. So this ice mountain in the sea ice mountain, what is the amount or what is the square kilometer this will be spread in terms of 2050? So that is the prediction we are making. That is one of the regression once again. Okay. So for that line, what will happen? You can draw a red line, straight line, that is the regression. Okay. So then again going back to that y is equal to mx plus c, depending on that you can really predict what is going to happen in the 2050. Understood? I'm taking a pause over here. Do you understand?